Hi, welcome to a conversation about selecting and maintaining trees and woody landscape plants. My name is Benjamin Hoover, and I'm a horticulturist and plant enthusiast. One of my favorite things to do is to talk about plants. So we're going to do that for the next 90 minutes or so as we look at plants and think about growing them well and using them well in home landscapes. I want to give you just a little background on who I am. So I spent 10 years in the nursery industry on the East Coast, serving the New York, Pennsylvania, New Jersey, Maryland market, Delaware, so the mid-Atlantic region. And I grew plants, I sold plants. The nursery I worked at did wholesale and retail sales, both as a production nursery and as a distribution nursery. So I not only grew plants, but I also bought and sold them in both wholesale and retail settings. This is me quite a while ago with a Stewardia. This is a Japanese Stewardia that I had that was in our retail display area. The nursery I worked for was called, or still is called, Bamerwald Nursery. While I was there working with plants, I got really interested in why they did what they did. So not just what's the best thing to do to grow a good plant, but why? What's happening inside the leaf, inside the stem? Why do some techniques work and some not work? So I went to Temple University and I did a bachelor's degree in horticulture, which had me study some landscape architecture and some horticulture. And I learned to love plants even more than I did in my time in the nursery industry. When I finished my degree and I had my bachelor's, I still had more questions. So at that point, I left the nursery industry. I wasn't actively full-time working in the industry anymore. And I went on and did a graduate degree at Penn State University in University Park. My master's degree, my research was focused on hemlock woolly adalgid. So I collected ovisacs of woolly adalgids, and I would put them on different species of hemlock trees and then look at the eggs as they hatched and as the nymphs emerged to see if they could feed and successfully survive on different hemlock species. And I was basically looking for resistance to the hemlock woolly adalgid. In addition to that project, I worked with fir species, so the genus Abies. I worked with primarily Nordmann fir, a little bit of Turkish fir too, and some Canaan fir. But I worked with Nordmann fir here, growing it in alternative production strategies. So fabric bags with root maker containers, various techniques, and looked at growing these plants in this production setting and then harvesting them to see what the root architecture looked like and the growth rates on the plant. So that was my master's degree. I finished that up and I had the same thing happen to me, that I still had questions. And there were many more things about plants that I did not know than I knew. So I kept on doing research. So I started a PhD and I worked with Phytophthora root rot and true firs, so Abies again. In this study, I was looking at the efficacy of fungicides in preventing Phytophthora infection. So what you're seeing here are little planting beds that are simulating a seed bed in a conifer production nursery. This funding came from the Christmas tree industry. So they're growing these Christmas trees, starting them as seedlings, and they were losing a lot of plants to Phytophthora. So I would grow Phytophthora on rice and put that rice around the plants and then attempt to protect them with fungicides to see which fungicides worked and which ones did not. So I did that. I also did many studies where I would collect. So Pennsylvania has a database of basically dead plants that are sent in to the plant pathology lab. And when the plants are analyzed, some of the pathogen is kept behind and kept in vials. So I went at Penn State and then also in the state capitol where they have another pathology lab, I went and collected all sorts of Phytophthora that had killed trees in Pennsylvania in Christmas tree settings. And I took them and I used them to identify some of the worst for the pathogens. And then I screened many firs for resistance to the particular Phytophthora. So that involved plating out the Phytophthora. Here I'm growing it on V8 agar, and then lots and lots of young trees that will then be inoculated with rice and Phytophthora to see which ones survive. Here is a rhizotron experiment I did then where I upped the level a little bit of Phytophthora, but also flooding, and looked at health of trees in flooding. So I did all of that stuff, right? That led me to eventually end up at Cal Poly. When I finished my time at Penn State, I still had questions. It didn't end, right? The bachelor's degree didn't answer it all. The master's did not answer it all. The PhD did not answer it all. So I'm still curious, and I'm still learning, and I'm still growing in my understanding of plants. And I get to do some wonderful things of teaching classes here at Cal Poly, doing research, and hopefully making other people excited about plants and helping them understand them better and ask better questions. A big piece of being educated and of being wise and of knowing things is understanding what you don't know, understanding how to ask a question, how to continue to develop your understanding to go deeper than what you had before. So that's what I get to do with students here at Cal Poly. I've been here 9 years. I teach classes related to plant production, like horticultural production techniques and plant propagation, and then also things focused on plant selection, like Plant Materials 1 and Plant Materials 2, which has many landscape architects in the class. So today, what we're going to do is talk about selecting plants, which ties in very closely to the plant materials classes that I teach, and my background as a horticulturist in the industry. So we've got some goals for this video that you're watching, this training video. The first goal is to be able to discuss appropriately selecting woody plants for home landscapes. So we're going to cover this idea of selecting a plant, some of the things we need to think about. And hopefully by the end of this time frame, you'll be able to have a conversation and discuss some of those factors and what they might look like. We're also going to have the goal of being able to describe proper tree care, some of the factors that are involved, and some of the considerations. This will be on a general level, not tons of specifics, big picture ideas. What facets are involved in proper tree care? And then lastly, we are looking at demonstrating awareness of ecological and practical implications associated with woody plants. So there are factors in selecting a plant, and we have factors in tree care, but there also are big overarching situations that are happening around us that might be new. In other cases, they may be old, but they're pieces of information that we might want to think about, continue to evaluate as we work with plants. So we're going to do some little case studies in that area to focus on questions centered around pertinent issues in California right now, working with plants. So let's start with this first part. We are going to look at selecting woody plants for home landscapes. So we are entering part 1, selecting a woody landscape plant. So how do most people select plants for their home landscape? Well, I think we'd like to say it's a well thought out, careful process. But the reality is it is probably frequently an impulse purchase. Maybe based on aesthetics. A flower looks really good, or the foliage looks really interesting in the garden center or nursery. Or maybe it was a price. Maybe there was a sale. Maybe you walked into Home Depot and there was a little display and the price was low and the plant looked good, and now you have it. It goes in your landscape. Maybe it was convenience. You just needed a plant. It was there. You have it. Maybe it was gifted to you. Maybe you didn't even choose it. Maybe somebody gave it to you. Well, no matter how you end up getting a landscape plant, if we're really trying to stop and think through the process before we install this plant in our landscape or select where it goes, we need to understand it's a very complex process. As I teach classes about plant materials and plant selection and plant growth, one of the things I'm continually telling my students and trying to help them understand is that many people think of plants like a sofa or like a table, or if you're outside, like a new mailbox. It is something that you look at, you like the look of it, you put it in its place, and it does its role, right? It does its function. But that's not what a plant is like. A plant is more like adopting a pet. So it's like getting a puppy. It's like getting a cat. It's alive and it has needs. It needs space. It needs soil, it needs nutrients, it needs water. It's a living organism that has needs. If you ignore those needs, the plant is not going to do well, and likely it's going to cost you. There's going to be a consequence for you as well. So plants, we need to remember they're alive. They are living things. When we're selecting a plant, if we remember this, that plants are alive, that will help us set them up for success. But we frequently have a goal. Sometimes it might even be multiple goals. But whatever the goal happens to be, we need to take that goal and then kind of walk through a series of steps to make sure that we've done our due justice, that we've actually gone through and verified this plant fits for us. It's a good idea and a good selection. So first off, if we're thinking about identifying one of the goals, we want the plant to thrive. We don't just want to get a plant or put a plant in our landscape. We want a plant that is thriving, that is growing well, and that is healthy. So we want a healthy plant. However, there's another aspect. Usually when we go to select a plant or add a plant to our landscape, there's something else we're looking for. It might be shade for our patio. In the middle of the day, we don't want the sun to hit us directly, we want shade. Maybe it's a screen. Maybe we don't want to look at a road that goes by our house, or maybe it is another window from another property we want to screen. Maybe it's scent. Maybe you want to smell something in the front of your house or close to your patio or walkway. Maybe you want a rose there, or you want something fragrant. Maybe you want a flower color. Maybe you want to look at a particular flower color in a site. Maybe you want a product. Maybe you want to cook with herbs. And so you want to grow the plant that's going to provide the herbs that you need for your culinary use. Who knows what it might be? You might have some added goal or goals that are very specific that will narrow your focus down on certain plants. Other times it might be very, very general and open. So here are some considerations where we might start to think about selecting a plant. So remember that first goal, a healthy plant, a plant that is thriving. Well, we have resources that we can use that help us put a plant in the right spot, the right location. And when I say right location, I'm thinking big picture now, as in the right general region. There are various maps that have been developed, I should say, to help us pair plants with place. Now, this is on a big level, on a macro or large climate level, not a tiny level, like not subdividing your property or maybe a job site into multiple zones, but instead looking at the region and putting it into a zone. So depending upon where you're located in the United States, you might use different zones. If you are on the East Coast, in the Midwest, and in parts of the West Coast, you may be really interested in the USDA Hardiness Zone map. And in fact, nationally in the US, if you say something about a plant zone, this is what most people will assume you're talking about. In California, we have another zone that is very popular. We're going to get to that in a moment on the West Coast. But hardiness zones are nationally, on a national level, the most popular zone. What are they? Well, the USDA hardiness zones are developed from data that look at the mean annual minimum temperature in a region. So what you're looking at here is saying, not how cold has it ever been recorded to get, or what coldness is likely this year. We're trying to predict for 1 year. Instead, we're saying, let's just look at data. And the most recent revision was in 2012. Let's look at a series of data and identify this range of how cold it has tended to get. What's that mean coldest temperature? So the country is divided into these zones. And when you're looking at the zone, from looking at the overall map, it's hard to tell where a particular town or maybe even a county falls, because this map we're zoomed out and looking at the entire US. But you can go to resources online that allow you to put in an address and see a magnified zone up close where you can determine very specifically which zone you fall into. The zone map can also be divided into sub A and sub B. For instance, zone 1 here has a 1A and a 1B. So zone 1 the mean minimum temperature is -60 to -55 degrees Fahrenheit. That's very cold. You will see that most of the country is down here, close to something like zone 7A. We get a 0 degrees to 5 degrees Fahrenheit. Moving forward to the central coast of California, we're looking at zones where we don't go to 0 degrees Fahrenheit. We're considerably higher than that. But this map is designed to help you predict, can my plants survive the coldest temperatures in this region? It doesn't tell you anything about how hot it gets, how much water is there, the elevation, the soil type, nothing about that. But just, can my plant survive the temperature, the minimum temperature? And once again, this is a general map based on the average minimum temperature. It doesn't cover little microclimates that might be warmer or colder than the surrounding area. So this is not exact, it's not perfect, but it's a general guideline. Now, how do plants fit into the map? It's based on the opinions and the recommendations of experts, of horticulturists and people at botanical gardens and with landscape companies and nurseries in academia. They provide their perspectives, plants get assigned zones, and then you can look this up to see if the plant is likely to be able to survive in your particular zone. There is also a series of zones that factors in the other side of the equation, heat. The AHS, American Horticultural Society, heat zones were devised to look at the number of days in a year in which the atmospheric temperature exceeds 86 degrees Fahrenheit. So you might say, why 86 degrees Fahrenheit? That seems very arbitrary. Well, the reasoning behind this standard or this area of measurement is that many plants start to experience cellular protein damage as we approach 86 degrees Fahrenheit. We might call a plant heat stressed. We might say it can't cool the tissue quickly enough. But many plants that are sensitive to high temperatures will start to experience trouble at 86 degrees Fahrenheit. Some plants, like many succulents, tolerate very high temperatures and do that very, very well. However, extreme temperatures can be problematic for plants. This map is one that is a wonderful and beautiful concept. I really like this idea, especially as we look at rising temperatures and the effect of heat stress on plants. I think there's a lot of potential here. Unfortunately, Dr. H. Mark Cathy, who developed this, he passed away, and since his death, we really have not had anyone take this project on and move it forward. So we have the data from weather information. This last publication was 1998. So the data, the map itself is already somewhat out of date. But the real challenge has been putting plants into the proper zones of saying, where does this plant grow well, where does it not grow well? We have not had that many observations, and there hasn't been that much work to accurately put plants into the right zones, to communicate well which plants fit where. So while this map, I think, is interesting and is valuable to think about, it's hard to find good practical information for the heat zones. Plant zones or sunset climate zones on the west coast of the United States are very, very valuable. They're not perfect, but they're a valuable resource. So the sunset climate zones are based on data that involve the humidity or the precipitation that you'll get in an area, the temperatures, the minimum and the maximum, the soil types, the elevation, all sorts of factors related to climate, puts them all together and gives a series of zones for the West Coast. This is broken into a subset of maps for regions. Here's the one for the central coast of California. And you can look up your zone. Now, the sunset climate zones do not have a very, very clear organization from low to high with one factor. So the USDA hardiness zones, zone 1 is very cold, and as the numbers go up, it gets warmer and warmer relative to minimum temperature. For the heat zones, zone 1 has no days above 86 degrees Fahrenheit, and then as the zones go up, you get more and more days above or at 86 degrees Fahrenheit or above. The sunset climate zones don't have a direct connection to 1 through the 20s, right, as they count up. Instead, you have to read about what the individual zones mean. In a very general sense, they go from cold to warm, but it is not a perfect relationship because they're far too complex to put on a simple linear scale. There are some areas in California where there's some dissatisfaction with the sunset climate zones. Some people believe that they don't work so well in their area. Some refer to hardiness zones instead. Other times they say find a good garden center in your area. You can get better recommendations there. But it is a powerful resource and a good starting place as a predictor. So how do we use these zones? Well, you look them up in a resource. You can find many of them online. You can find many publications that will list zones in them as well. So you can look to match your plant with the appropriate zones. Many nurseries that have online catalogs or online resources give you the ability to look up zones, but then also put them in as selection criteria as you search for plants. So a helpful starting place is selecting the zone that you're in, find the zone that you're in, and then limit yourself to plants that grow in that zone. However, there are exceptions to this. I am talking to you right now from my office on the Cal Poly campus. And on this campus, we have many plants that on paper should not be growing in this zone. And they're thriving. They're in particularly warm microclimates, close to, they're on the south sides of buildings with light-colored walls that reflect light down on them. They're protected from wind. So they're in places where they can survive where many books would say they couldn't survive in the overall region. But the microclimate is favorable. We also have little courtyards or atrium areas where we have plants growing that, once again, don't seem to be appropriate for the area, but they're thriving. So identifying the microclimate is helpful, and that's where we're headed right now. So the actual setting, the site where you want to plant your plant, is critical because the site, the zone that we're looking at in the maps covers a big area. Geographically, it's a large space. But we all know that on, say, a residential property or a commercial property or a college campus or a commercial building complex, there are microclimates. So when you go to plant your plant, you know that the different sides of the building have different sun exposure. Maybe there are different soil types, different water availability. These things will influence which plants do well and which ones do not. So the first consideration we're going to look at is sunlight. Sunlight is often described as full sun, part shade, and shade. These terms are not perfect. I think a lot of us, when we say those words, you have an idea of what that means, but sometimes people will say, well, what's the difference between part sun and part shade? How do I quantify that? One, I tell people not to get stuck on logistics or the specifics where you're trying to split hairs and be right. The big picture is saying, as we're looking at a plant, where does it thrive? Well, full sun is usually 6 hours plus of sun per day. So you want about 6 hours of sunlight in a daily time period. So that's generally going to do well for full sun, more than 6 hours of sun. For part sun, you would have something like 3 to 4 hours of sun, 3 to 4 hours of good sun, and ideally it's peak sun. It's right around noon if you can be ideal about it, where you have direct sunlight in that most intense period of the day, 11 a.m., noon, 1 o'clock, somewhere in there, you get some sunlight on your plants. Part shade is frequently meaning that you have protection from that peak sun. So the most intense sunlight in the middle of the day, maybe 10 a.m. to 2 p.m. or 11 a.m. to 2 p.m. in that window of time, you have protection from the most intense light of the day. And then full shade is where you don't tend to have direct sunlight. It's indirect, it's filtered, it's blocked. You don't have full light exposure. So these are somewhat loose in category. If we're trying to understand on a scientific level, when does a plant do all right? When does it not do all right? One of the things we might look at is the daily light integral of the amount of light in photons a plant gets in a day. We also might use units to quantify the amount of light the plant is exposed to in a given time or a given moment. You can use the eye test This picture on the screen shows the side of a building here on campus, the Cal Poly campus, where for much of the day there is shade provided by a building. It blocks some of the sunlight. And so you can tell just by looking at this, you don't need any fancy equipment to tell that there is shade in the majority of the landscape bed, but there is one edge that remains brightly lit through the day. So assessing the sunlight available will be valuable because some plants will require sunlight, some will require shade. And if you put a plant that thrives in full sun in a shaded location that has shade all day long, you're not going to see healthy growth. You're not going to see a plant that's going to thrive and be healthy and do well in your landscape. So providing the appropriate amount of light, siting the plant appropriately is critical. That's very important. We could also look at the soil. A really good step if you are a gardener or you're working with your soil is to test your soil, whether that's sending it to a laboratory for formal testing or inspecting it and evaluating and looking at it yourself to look at its texture and structure. We have a massive range of soils in California and in North America in general. So with soil and siting plants, we might need to evaluate if the plant we're working with has very specific needs. For instance, the plant in the upper left corner here with the multicolored leaf, this is not a fancy cultivar that has chartreuse colored and green colored leaves. This is Quercus palustris, pin oak, that has an iron deficiency caused by high pH. The high pH causes iron to oxidize in the soil and then it can't be taken up by the plant. And so we see an iron deficiency in the plant. So the plant itself, the iron was and would be present. You know, if it was in the soil, applied to the soil, it's naturally found in the soil, but it's oxidizing and it's not available to the plant. So the plant is growing and surviving, but showing these symptoms of disease, really something less than health, due to the fact that the pH is too high in the soil. So we can lower the pH in the soil to grow this plant there and make it healthy, or we can provide chelated iron, iron that's protected from oxidation. Either one of those things will get us through this problem, but this is an example of a tree in the wrong soil type for it to grow and be healthy. Here we've got turf. This is on a campus on the East Coast. This is the Penn State campus. Anytime a sidewalk has a connection by direct path that is not really supposed to be part of the sidewalk, it generally will be made a path. And so in this case, you can see where people took this shortcut to avoid walking through the actual sidewalk, walking around on the actual sidewalk. And when that happens, you get compaction. The compaction causes a loss of porosity. So porosity is pore space. It's space for oxygen to be held, for water to be held. And then in that water, often nutrients, and nutrients will bind to the substrate particles or soil particles. When people walk over the turf and the ground, they pack that together, and all of a sudden you have a place that is not good for growth. So in this case, the soil is very compacted. Some plants grow well in compacted soils. This turf, not so well, and many trees, not very well in highly compacted soils. Some plants thrive in soils with very high amounts of organic matter. And when I say organic, I don't mean certified organic. I mean carbon-based, things that were alive. So this is a Dicentra pulsiflora. I saw this on a hike in the Mineral King Valley, up in the hills above the Mineral King Valley. Several years ago, I took this picture. And what it's showing is this small herbaceous plant. And if you look, this photo captures the soil that it's growing in with these little pieces of branch and bark and needles, all sorts of organic material. This isn't growing in just rock, but it's a soil that is high in organic content. So there are going to be some plants that will thrive in soils high in organic material. And I think immediately of the Ericaceae, things like rhododendrons and azaleas and laurels and many of their relatives that thrive in soils high in organic matter and often very acidic when it comes to pH. So understanding the needs of a plant for the setting or the setting you're working with, if you know what you have, then you might have an idea of what you need to amend or what is going to be appropriate for that particular site. So the soil and is part of the setting that you're planting your plant. You may be limited by that, or maybe you have options in your property or the place where you're working. It's important to understand the soil will be important. Another thing to consider is space. So the space that you're working with, where is it that you have windows that you either do want to be blocked or you do not want to have them blocked? One common place where people have problems in home landscapes is their sidewalk. Many people plant a plant too close to their sidewalk, and they end up fighting a battle of constantly pruning or shearing that plant to keep the walkway unobstructed. So you want to consider that. I have this picture in the slide set right now as we're watching this. This is an example of Callistemon viminalis, which has actually scientifically been renamed Melaleuca, but right now is still going by Callistemon viminalis, so little bottle brush, weeping bottle brush. It's planted here in front of this sign for Chipotle and Five Guys down in the Five Cities area. Now, this is the cultivar, either Little John or Captain Cook or one of the compact cultivars. And on a label or in a book, they will tell you the plant grows to 3 feet tall. If you're ever in the Cal Poly Arboretum, the Leaning Pine Arboretum, walk up to the main lawn and you'll see some old Little John bottle brush that are 8 feet tall. That's how big the plant gets eventually, given time. So they'll be short for a decade, maybe 15 years, but eventually you have a 6 to 8 foot tall plant on your hands when you plant Little John bottle brush. In terms of siting or space, the Five Guys sign is very low. This is just a couple of feet above the ground, way too low for these particular plants. So this is an example of a planting that's going to require maintenance. These plants will need to be sheared down below that sign. I've seen many development signs at the entryway of developments that have plants planted around them that obscure parts of the sign, or sometimes house numbers inside of a complex. All of these things are an example of not working appropriately with space. So it's worth thinking about, do I need to get a cultivar that is very compact? Do I need to select a species that is small in general? Do I want to avoid large species? Don't be deceived by the starting size of a plant. Small plants can grow. You want to be aware of what is the expected full size for this plant. So as you think about the space you have to work with, that's an important consideration as you select the size of the plant you will put in that space. There are many more things we could talk about when it comes to the setting where you're putting this plant. But we're going to move on to another factor that is sometimes tied to the space, sometimes not. But it's a critical factor in California, and that is water use. So when you select a plant, for many plants, you can get an estimation of how much water will be required. In some places in the United States, this is important. In some places, it's not very important. Here, it matters. It's really important. I took this headline just the other day, looking at the NBC News of the kind of header for the subcategory of California drought, where they have coverage, and they're talking about the number of people in California under drought emergency and what that future might look like. It is a serious issue in California. Water is precious. We do not want to waste it. And so in a landscape, how can we be responsible with our plants? We can be aware of what the predicted water use of a plant is. So there is a document that is sometimes called WUCLS. WUCLS is the Water Use Classification of Landscape Species. So this document has been constructed. It was initiated and funded by the Water Use Efficiency Office of the California Department of Water Resources. And the work was done by the University of California Cooperative Extension and San Francisco and San Mateo County offices, and a few others involved in the project. It was first published in 1992. It's been revised several times. We're on the 4th edition right now that came out in 2014. And what happens in this document is plants are evaluated and they're given a percentage of the evapotranspiration rate, or ETO. So you'll see this in this little piece on the upper right corner of the screen. The way this is calculated is the ETO, that is the baseline, that is 100%, is defined as the water loss from a planting of cool season grass that is 4 to 7 inches long and is not water stressed. So a cool season grass that has some height to it is going to require a large amount of water to survive and to not look drought stressed. So that is our upper boundary for water use. And then plants are categorized as either high water users. Those take 70 to 90, or you could say 70 to 100% of the ETO of that grass, that cool season grass. A moderate water user is 40 to 60%. A low water user is 10 to 30%. And a very low water user will be less than 10% of the water that turf grass would require. So when you're making this evaluation, it doesn't take a lot of thought to realize water use isn't the same everywhere, right? If you're in the middle of the desert in California and it is hot and it is dry, things are going to dry out rapidly in that environment. If you go to a cool coastal setting where there is a marine layer, things are not going to dry out as fast. Now, for some species, they just won't grow in the desert. They won't be able to survive there. But for some plants, they can grow in some of these hotter, drier environments, but their water needs will be higher if you plant them there. And if you put them in a cooler location, they may be lower. So for this reason, WUCLS divides California into regions. They have six grouping regions. The North Central Coast region, which is the zone that the Cal Poly campus is on here at San Luis Obispo. So that is the first region. We have the Central Valley, the South Coastal region, the South Inland, High and Intermediate Desert, and Low Desert. And you can see the corresponding sunset climate zones here, and a couple representative cities that are mentioned right here as well. When you're looking at the listing, you just see lots and lots of plants listed out, and it will talk a little bit about the plant type, what sort of plant it is. It has its botanical name and a common name. And then for the 6 zones, it lists one of these water codes. And it may be unknown, there may be a question mark, there may be a slash, meaning that the plant is not recommended for that place or that location. Those letters and the valuations come from a panel of experts. So this is subjective. This is based on observation of saying how much water is required to make this plant look healthy and grow well in this landscape. And so you get this rendering of an opinion, right, of what it would take based upon these panel of experts. So this is not a perfect reading. The result you get with water could be determined somewhat by your soil type. If you have very fast draining sandy soil, you might not be able to keep water in it. Water may not be held long. If you have a clay soil, it will hold water for a longer period of time. If you have something growing on a slope and you're trying to irrigate it and the water's running off, you might not get away with the bare minimum number of what they say here if you're not very careful to avoid any runoff of the water. So you have to be careful. This is not an absolute, but it is a guideline of what to expect with your plants. There are other resources, like here's Landscape Plants for California Gardens, written by Bob Perry. He is an emeritus faculty member from Cal Poly Pomona. And in that book, he has some data and information about irrigation that is very similar or based off of the WUCLS document or something very similar to it. And it looks at the projected amount of water required over time for the plant. And then it also breaks plants into these irrigation zones or groupings. A helpful book to help calculate a water budget and to think about the role of water in your landscape. However you choose to evaluate water, it's something to think about. Be aware of that not all plants have the same water requirements. And as you're putting them into your landscape, it makes sense to keep plants together that have similar water requirements. So it would not be a great idea to have a surrounding of desert plants or very low water users and then a few medium to high water use fruit trees right in the middle of them. As you're trying to water the fruit trees, you're going to be putting way too much water on your desert plants, and you're going to have a problem, right, in that scenario. So you want to divide your landscape into areas if you have differing water requirements. Ideally in California, we're looking to minimize our water use if at all possible. So we want to do our best to be responsible with the water we will be using to keep plants alive in our landscape. If you end up using plants outside of California, this might not be much of a consideration. I grew up in Pennsylvania where it rains every week or every 10 days in the summer. And so you don't have an irrigation system. The plants are watered, free water out of the sky, right? It happens reliably every summer. Once every several years, you'll have what they call a drought there, which is nothing like a drought in California. And the plants usually just go dormant and then bounce back when the rain comes again. So this is not universal, right, for the entire country. In fact, things are very different even in the Pacific Northwest. In some regions, we have much less reliance on irrigation systems. But in California, this is a critical part of the conversation. There's something else that we might think about. I've just talked about California and Pennsylvania and Pacific Northwest, and I've mentioned some states and talked a little bit about this concept. When we think about the potential for invasiveness, when we think about a plant that is invasive, I believe for many of us, our first instinct, our first impulse is not right. It's not a good thing. It's not helpful for the conversation. And that is, we tend to think about state lines, and we tend to think about a plant aggressively growing everywhere. But that's not really what an invasive plant is. Usually we're evaluating on state levels, which is part of the confusion. And many plants that cause harm do spread quickly, so that also causes some of the confusion. But to really go back to why a plant might be invasive, we have to understand that one, it is simply non-native to the ecosystem. It's not a big deal if it's non-native to the state. A state line is a human construct, right? Northern and Southern California are separated by a lot of land. And there are parts of, say, Mexico that are far closer to Southern California than Northern California is to Southern California. So saying something is a California native doesn't mean very much in terms of whether or not it is invasive or not invasive. When we're talking about measuring invasiveness or potential for invasiveness, we want to say, is it native to the ecosystem where we're going to be planting it? And just because it's non-native doesn't mean it's invasive or it's a problem. The follow-up, the next piece of the question is important. Will it potentially cause harm to plants, wildlife, the soil, to humans? That's what makes a plant invasive, not rapid spread. Rapid spread causes harm to other plants in many cases, and sometimes to wildlife by displacing food and nesting sites. So the rapid growth can outcompete other plants and cause harm, right, in that scenario. But some plants that are invasive don't spread very quickly. They're actually rather slow, but they have a harmful effect on humans, on the ecosystem, on the soil, something around them, and that makes them a potential problem as an invasive plant. So how do we evaluate invasive risk in California? Well, like I said, it happens on the state level typically, sometimes a county level. So we're kind of stuck thinking about the state and this human construct idea as opposed to true ecosystems. In California, we have CALIPSI, or the California Invasive Plant Council. The California Invasive Plant Council looks at plants and provides evaluations and talks about what the risk is, and then you can read that evaluation and see where in California, which ecosystems are the most sensitive or under the most danger based upon the plant plant that might be invasive. We also have Plant Right, an organization that looks at helping the public and nurseries use plants well. We're going to talk about that in a moment. And on a big level, we have the USDA. And then various states in the United States, they have their own state agencies that may be tracking and looking at invasive plants. Well, Plant Right, as I mentioned a moment ago, they have information here where what they've done is try to narrow down to at least region, to identify where we're having potential issues with plants and focus on a regional level. So you might look at something like pampas grass here, Cordaderia siloana, and notice they're saying in these three regions, so NC category, the red dot is San Luis Obispo on the Central Coast. So these particular ratings, they all have the red NC rating. So their recommendation from Plant Right is to not plant pampas grass, to not plant Pennisetum setaceum or green fountain grass, to not plant Mexican feathergrass, stipa. We see a lot of this in landscapes right now. To not plant highway ice plant, Carpobrotus edulis. Periwinkle, Vinca major. These are recommendations on their website. If you put your cursor over these images on their website, they flip and on the flip card has recommended alternatives to put into landscapes. So this is one resource you could look at to say, should I be concerned about this plant? Is it one that I should maybe avoid in my landscape because of invasive risk? There's another factor when we talk about invasives, right, or invasive plants. And I put quotes around this because I don't mean it in the menace to the ecosystem on a large scale level. But this is instead plants that don't play well with others, or plants that can be bullies in a landscape or in a garden. Some of these are beautiful plants and shouldn't be discounted because of it, but we might want to be careful. We might want to put down a divider in a garden bed or plant it somewhere where it's edged. The Rhamnea culturi, right, some people refer to as fried eggplant for the appearance of the flower. Beautiful plant. This plant spreads by rhizomes and stems underground, and it will spread out and take over a space and sometimes not play well with others. If you have other large plants around it, if you have a sidewalk edging a bed, there aren't going to be any serious problems. This plant is not on an invasive plant list officially, but if you plant this, be aware that it's not going to stay tidy in one little location. It's going to spread. So that's something to think about as well. Beyond the official invasive plant list is this plant one that spreads? Does it grow rather aggressively, or does it tend to stay in its space? Something to think about. And that ties in with maintenance. As you're thinking about what is the impact to the yard work that will be required for me or for the company that I hire to do my yard work or landscape work, how much maintenance will this plant come with, right, when I add it to my landscape? So this is another helpful consideration. So there are many factors in the maintenance budget for a plant. Some of the things we could think about are, is there regular pruning or shearing required for how we want to use this plant? The picture in the bottom left corner of the screen here is a ligustrum that has been planted with this fence to kind of complete this border between properties, but it takes work to keep it looking nice and symmetrical and fitting that space in a clean fashion. That is multiple times being sheared per year. That's some work that's required. Tipu trees are beautiful, but they need some pruning usually, and then they drop debris. So here it is in the summer on campus, all the flowers, the petals laying on the ground, some of the parts of leaf laying on the ground. This will eventually blow away or move into the ground if it's an area we can let it go. But when it's a highly trafficked space like on campus, this is cleaned up. If you're planting this by a sidewalk that is used regularly, you're going to need to sweep it. You're going to need to clean that up. And occasionally we run into things like this sweet gum tree here that has been planted. You can't see clearly because of where the truck is parked, but they are side-by-side driveways. The sweet gum is planted between them, and the sweet gum has gotten so large that it has cracked both driveways and the sidewalks going into the houses, and so it's being removed. This is an example of not ideal maintenance. This is a plant that was not in the right place. It caused structural damage to the pavement around it, and now it's being removed. That's kind of the disaster scenario for landscape plant selection, when you put a plant in a place that it outgrows and then must be removed. But as we look at cleanup, as we look at pruning and shaping, these are all things that we may want to consider, because some plants will be relatively low maintenance, very little cleanup required. Others will require more. And one of the big comparisons is deciduous versus evergreen. Will the leaves drop? And if they do drop, do they drop as one large leaf, or are they little leaflets or small leaves that kind of break apart and don't require a lot of cleanup? Or is it going to be something that is going to require extensive leaf cleanup? All those considerations might be important to keep in mind. As we're selecting plants, we also might reach that place, oftentimes this is one of the first considerations, of the aesthetics. What does it look like? What goal do we have for this plant in our landscape? Frequently, we're drawn to flowers, whether it is beautiful flower colors and shapes. So Leptospermum, beautiful, beautiful flowering plant, different types of flowers in that species. Leptospermum scoparium, beautiful plants. Hydrangea are just spectacular. The lace cap hydrangeas are just amazingly exquisite. The combination of the sterile florets and the fertile ones and the different different shapes they have. Really, really impressive. We might have some kind of architectural design or vision if we're working with something like a Melaleuca or an olive, where there could be various forms of topiary or careful shearing and shaping taking place for a really unique addition to a landscape. There could be just a simple rounded tree. This is Acer Grissium, my personal favorite plant right here, that I really appreciate for the bark texture and color and appearance, and then the fall color that develops on the plant. Probably not the best fit for most of California, but it is a beautiful and an extraordinary tree. You might have the aesthetic function might be also somewhat functional, as in you want screening to be provided. And so then the question might be, well, are we talking about a 6-foot tall hedge or an 8-foot tall hedge? Are we talking about a 4-foot tall hedge? Do you care if there are flowers on that, or do you want it to be uniform green? So here we have a boxwood, a Japanese boxwood hedge that is green and relatively short, green all year round. This is an Escallonia hedge right here that you can see little bits of pink. So it will flower pink and develop some little fruit capsules after the flower. So a little bit less formal, but dense and much taller than the boxwood hedge would tend to be. These are some things we might think about of what color green and how tall. That might fit into our aesthetics for our location. And like I said way back at the beginning, this is often the driver for people seeing an impressive flower on display and they buy it. They want it in their landscape. That's not an entirely bad thing. We just want to make sure that plant actually fits right where we're trying to place it. Another thing we may consider, and this could be the driving force in selecting our plant, would be some additional use. We may have some utility that we're looking to accomplish. So it may be herbs that we want for culinary use. These are from an Italian stone pine, so pine nuts. I enjoy collecting those, and in this case it's a sun-dried tomato and pine nut pizza. They're an added benefit to having an Italian stone pine in the landscape. Or you can grow your own strawberries and use those for various purposes. Sometimes we may have herbs, we may have fruits, we may have some value added, some utility use for putting a plant in our landscape. This is sometimes a really important motivator, sometimes a non-factor. It depends on the setting and your desires. The last thing that we're going to talk about for selecting a plant is availability. So you can look in a book and you can find a wonderful plant that seems to check the boxes for you, but you might not be able to find it available anywhere. So availability is another thing to consider. Is this plant being grown? Is it available? Can I buy it? Can I purchase it? Can I obtain it? Or can I grow it myself from seeds or cuttings or something else? Is it really available to me? So this is one level. If you're shopping by going to garden centers and looking at plants, this one is covered. It is available. But if you're looking through books, if you are looking on the internet, if you're talking to people, it's worth making sure that availability is there, right? That you can find the plant when you're looking for it. So with nurseries and garden centers, many times you can look up availability online. You could also contact operations and ask them if a plant is available. But I believe it is worth knowing and being aware that many plants are written about. There are thousands upon thousands of species of plants, and many of them are very hard to locate. And so there's nothing wrong with wanting a rare plant or something that's hard to find. You just need to be aware of the fact that availability could be a big factor in the ability to actually get the plant in the ground in your landscape. So those are some considerations. There are some others that don't get their own bullet point, like don't forget to get proper approvals. Like you may have city regulations about what you can and can't plant, especially if you're near a sidewalk or near overhead utility lines. There may be a homeowners association that you need to consider to get approval before you plant, or they may have an approved plant list. Those things are worth checking. There also are sometimes other factors that you might not think of initially as you start your selection process, but things that you should factor in. And if you're choosing for yourself, you'll know these. These will factor into your decision making. If you're helping someone else choose, you might ask them, Are there particular plants that you like because of memories or that you have an association with? If you're trying to pick a memorial tree for someone, pick a tree that has a long lifespan. Avoid very short-lived ornamental plants that I think right away of prunus. So many cherry plums or flowering cherries are used as ornamental trees, and most of them won't live beyond 20 to 30 years long. For a memorial tree, it makes a lot of sense to stick with something that is not prone to disease issues quickly in its lifespan. So some of these are going to be pertinent to various areas, but it is helpful to stop and think about the big picture of what the tree is trying to accomplish. Do you want this to be in place for a long period of time? And what are you really wanting to get out of this tree? It comes back to that goal that we talked about at the very beginning. You want it to thrive, but what else do you want it to do for you? So that is selecting a plant. So once again, the goal for this section is to be able to discuss some of the factors involved in selecting a woody plant for a home landscape. So we've talked about some of them in the past 50-some minutes. This is a time where we're going to potentially pause if you want to pause the video and move around a little bit. We still have a good bit ahead of us yet. But we're going to move on to the section of describing proper tree care. So that's where we're headed in part 2. So caring for a tree or shrub. We're going to look at some of the primary tasks that are involved in caring for a tree or shrub and use some general guidelines or overview of what some of this process might look like. So we're going to look at planting, staking, pruning, mulching, fertilizing, and irrigating as general topics. So let's say you picked out a woody plant. You got it from the nursery, you bring it home, and it is now time to plant your tree or shrub. So first off, you take the plant out of the container that it's in, if it is a containerized plant, and what you might see are roots circling in the container. If you see this, you want to break up some of those roots so that they don't have a circular pattern when they go into the ground. So you could do this for trees, for shrubs. This is a Europs that I did this with, where it was very pot bound down at the bottom of the container. All of these roots are thick and circling. So the concern would be as those roots circle, they get thicker and thicker and then begin to choke themselves out, and you end up with a very poor root growth in the container. And they're also very reluctant to grow out into the soil. So what I did was I took my pruning shears, my Felcos, and just made a few cuts into the side, and then used my fingers to pull and tease the roots out so that they were no longer growing in a circular pattern, but were ready to grow out into the soil. And this is just a small little semi-woody landscape shrub that I was planting back about a year ago. You could do this for big plants or small plants. So what we want to avoid is, here was at one time a small root that was circling around close to the bottom of a trunk. But if you look at this picture, we have a looming crisis, and that is the vascular tissue runs right under the bark, right here, right with the phloem and the xylem. And as this grows out, and this root grows this direction, this root is going to girdle or cut the vascular tissue off. And if the circling is severe enough, could actually kill the tree. The tree could die and be lost, even though it's quite old in the landscape. So the best management practice for this would be to sever the root as early as you notice it circling. Ideally at planting. If you miss it at planting, then do it later, as soon as you notice it. Circling roots are a major problem. So if we have taken the roots and we've gotten rid of a circling pattern, but we have them loosened up, and we don't want to knock them all free and destroy the entire root ball, but we don't want circling happening in the root ball. Then we dig a hole for our plant, our shrub or our tree. And this is where the advice gets really controversial, and there are many opinions, and you'll hear many, many things about how do you dig the hole? Is it 2 or 3 times the diameter of the plant? Is it the size just bigger than the plant by 18 inches or so? Is it deeper than the plant? Or is it just to the depth of the plant? You'll see recommendations regarding all of this about do this, don't do that, dig it deep, don't dig it deep. Here are some of the things that I would tell you that I believe apply on a large scale. Some of the smaller details aren't so important. 1, you want the root flare where the roots, the trunk and the root system meet, and you see the first root coming off or the little curve of the root system starting. You want that at the ground level or slightly above. I usually try and plant it about 1 inch high. And then if any settling happens, I'll be covered. I won't have a problem. So you want the root flare at this soil level or just above. That's really important. So when you're digging your hole, the depth, if you decide to dig deeper and then leave a little plateau, here is a photo showing that. Here's the little plateau and then dug down just a little bit on the other side of it. You want to make sure that this plant does not sink down, causing it, the top of the root ball or the root flare, where the roots begin, to be lower than ground level. That is a definite occurrence that you don't want to have happen. The size of the hole, this is going to be dependent on what you're digging into, what the soil is like there. My recommendation would be, if you're planting in very poor soil that's not good, then you should amend the larger area where you're planting the plant, not just right at the planting hole, but an area around, and usually focusing your attention on the top 12 to 18 inches of the soil. And do some amendment, maybe with a compost or with some kind of organic material that you're mixing in. So that would be okay, but you want to think about treating a space, not a planting hole, when you do that. In general, I would not recommend putting an amendment into the backfill, mixing it together and then putting it back in the hole. Once again, some trees will survive if you do this. It's not like you're automatically killing your tree, but what you're creating is effectively an in-ground pot in many cases. You also, with many amendments, if you're putting them into a planting hole, you're risking having a high salinity level, lots of ions, and oftentimes things in compost, if they're concentrated into a small space, you can end up with poor root growth due to the high salinity levels. So I would not amend just the backfill in a planting hole, but I would either amend the larger space or put just the natural substrate back into the, or natural soil back into the planting hole. You want that to be packed, but not packed too aggressively. So what I usually do is stand on the backfill as I'm putting it in, fill some up, put a foot on it, stand on it. You don't want to be jumping up and down and pounding every last little bit of pore space out. This is also something you want to be careful. If it's really wet, you don't want to do a lot of stamping and jumping on it. But if the soil is not fully wet, you can step on it a little bit more. When you water it, things will settle as you irrigate your plant. When you're digging the hole, one other thing to note. So in this diagram, you see this side on the hole right here. My usual advice for when I was having planting crews go out and plant trees when I was in the nursery industry, and now when I talk to people about planting plants, is you want the sides of the hole to look rough. That's your goal. You don't want it to look smooth, especially if it's in clay. In clay, that should be a big warning. You don't want a smooth clay side on a hole. If you're using an auger to plant, you want to be really careful about an auger that drills down into the soil and leaves a smooth ring. Looks like you've created a pot right in the ground, smooth sides. That's a really bad sign. I'm going to show you a picture in a moment to illustrate this. So what I would do when we planted with augers, the nursery I worked at, we would go back with a shovel and cut into the side so it was all irregular. Just chop it all up so it's all textured and slices into it, very irregular in shape. If you're hand digging, I still do the same thing. Drive my shovel into the side so that it's very irregular. So what you're trying to avoid, especially if you have clay, are smooth sides. So this is an illustration with marigold that I did in a class here at Cal Poly. And I had to use marigolds in herbaceous plant because we run on the quarter system 10 weeks long. So everything's a sprint to get to the finish. And when you do an experiment, it has to happen fast. So I couldn't use many woody plants that take a little longer to grow. But we used these marigolds and we potted into a clay soil. So this plant right here, the clay, what came in it wasn't soaking wet and it wasn't completely dry. It was kind of that in between. And we planted the plug that the marigold was in into that clay. And when we dug the hole, we kept it very irregular and loose, and then we backfilled and watered the plant in. And after about, I think it was 6 weeks that we let it grow, when we went to take the 4-inch pot full of clay out, the roots were all through the clay, and it was one big block of roots. So the roots had fully explored the container. When we went to this plant, when we planted this plant, we took the clay and we dug a hole for the plug. And then we wet down the clay and we took our fingers and we glazed the sides. We made them smooth. And then we stuck the plug in and we filled soil in around it, and then we watered it in. So the difference was a rough edge in this plant and a glazed edge in this one. After the 6 weeks of growth, this was the root system difference. So the rough edge, the roots grew all through the soil. The glazed side, the roots barely got into the clay. So that glazed edge, the particles were so smooth and so well sealed off that the roots just began to circle around and grow around, but they were not able to get out into the clay. In fact, when we took the 4-inch pot, we took the clay out, we saw no roots out on the edge of the container, right on the sides. So we had to break open that clay to hunt for the roots. And they were stuck in the initial plug back in the center. The reason you're not seeing the plug on this one is it's back inside and the roots are all the way out to the edge of the container and growing all over the place. So they're just all through the 4-inch pot that the plug was transplanted into. So when you're digging a planting hole, when you're planting your plant, the key, do you dig it deep? Do you dig it shallow? Do you dig it wide? Do you dig it short? I don't think that's as critical as saying keep the root flare at soil level or slightly above, so it's not too deep, and then make sure the sides are very irregular and not smooth. And if you're going to make amendment to the soil, amend the larger area before you plant. Don't just amend the planting hole. Right? Those would be my pieces of advice. How about staking? This is another one that can be somewhat controversial. Do you stake a tree or do you not? My personal preference or opinion is I try to avoid staking whenever I can. I would prefer to grow a tree unstaked. And my question for you is, when's the last time you were hiking somewhere and saw a tree in nature that was staked, right? It's not natural to stake a tree. Now, we also don't see trees being transplanted in nature. But when we are looking at staking, there are times where it's unavoidable. If you plant a large palm, they have a very small root system. When they're transplanted, you will need to provide some support and staking. This is a palm in slow recently that was transplanted, and it requires the staking to stay in place. Here's a street tree. If you're looking at this picture, there is a clue about where this picture is at. This is not in California. This is in the Pacific Northwest, and you can just see the top of the Space Needle right there. This is Seattle. So this street tree has a stake on either side and an attachment. So it's not heavy duty. It's going to be able to flex a little bit and move, but there is some staking present in this case, and there are likely some wind that's involved in this particular area. So this is an example of staking to provide a little support in the case of wind. Here's another option with staking with ties that go right down to the ground. And these stakes are paired with a wooden stake tight to the tree right here. So there's a wooden stake tight to the tree and then a tie off. This tree shouldn't be moving much at all in this particular setting. Well, is staking required? Is it not? My personal goal when I am planting plants is to make sure that my plant has the ability to flex with the wind. I don't want it so rigid that it can't move. However, if I'm in a place where there is enough wind or there are enough conditions that the tree will end up very crooked as it grows, then I do provide some staking. My usual goal is to attach with a stake. In many cases, I use bamboo or something that can flex, that can move, and then to make sure that I don't cause damage on the trunk or the branches in the act of attaching. And as soon as the plant is self-sufficient and can stand, get rid of the stake, remove it. The problem, right, would be one, staking too long and keeping the tree artificially weak by providing support. And then two, eventually the plant will grow into the staking material and you'll damage your plant long term. This is a cherry plum that has grown right through the staking attachment and incorporated it into itself because it was not removed in time. That would not be best practice for staking a tree. So staking is a maybe. You might need it if the plant can't maintain a good angle as it's growing, but You don't want it to be completely rigid, and then remove it as soon as is appropriate in your setting. If you're getting a tree with really good taper and healthy and strong growth, you shouldn't need to stake for a long period of time. Usually the first year, maybe not even a full year, would be required. If a tree has really small caliper and is really thin, it might need support for a longer period of time. However, the more you stake a thin tree, the slower it will add caliper or stem growth. So it's really important that if you have a really thin tree that you do want it to be able to move a little bit, because that movement changes the allocation of resources down in the trunk, making it thicken up more quickly. So that's staking. What about pruning? Pruning is something that is not necessarily automatic at the time of planting. And as you get ready to take care of a plant, when you are watching a plant as it grows and matures, the question is, should you prune or should you not prune? Well, you're generally pruning to deal with poor branching structure. So something about the shape of the canopy or the branch arrangement is not appropriate for the future. And that might be to forming the leaders of the plant. This is an example of Lophostomo, the Brisbane box, in which case we have a couple of leaders going up here. Eventually we're going to have like 3 primary branches going vertical. There's this really awkward split down low, which should have happened back at the nursery, is one of these 2 branches should have been removed and the other branch trained up as the central leader and then branching from there. So this tree is doomed to a poor structure over time. Not ideal at all. There also are crossing branches here. This tree is really a nightmare. I'd say of any one that I've seen planted recently on the Central Coast, this is probably the worst quality product in terms of what's going on in the canopy here. Hopefully they got a really good deal on this, and it probably wasn't worth it. So in this case, we are cleaning up to solve a problem. Here is another example where we might have a problem. So this is a calorie pair, and we have many branches arriving from the same arriving at the same location or coming out of the same location. You can see a pruning cut was made here and one was made here, but this is long-term going to be problematic. Ideally, this would have been solved earlier, before this stage. Now these pruning cuts would be pretty traumatic. So if this had been made earlier, we'd have a healthier and better branch structure on the plant. An example of the late correction, this is a calorie pair as well, that was corrected at a similar stage of growth as the previous picture. So you see these big cuts made on the branches. So you might say, okay, they solved the problem. There now are these 2 branches instead of this cluster. However, this was the outcome. This is what the tree looks like. And the question is that success? Does that look good? Or does it look like a poorly formed calorie pair? I would argue that it just looks like a poorly formed calorie pair. The motivation for pruning this tree was this street had calorie pairs on both sides of it. And on the other side of the street, the calorie pairs broke apart in a storm, many of them. And so the landscape company maintaining the other side of the street saw that and said, we should reduce the number of primary branches in this location so we don't have the same problem, instead of doing it proactively, knowing that's where the tree was going to grow to in the future. So this was an example of trying to make up for lost time when the pruning should have happened 5-10 years earlier, not when it did. If you avoid the pruning, that's what happens. The tree just breaks apart. This is a calorie pair that broke apart in a storm, some rain and a little bit of wind, and it just fractures at that connection point. We also might see something like here is a Japanese maple, where 2 branches are growing closely together and rubbing. And if you let the secondary growth continue to happen on those plants, they will grow together. They might even fuse, but you're going to have 2 branches that will not be fully healthy. It'd be far better, far preferable to take one of those branches out and let that occupy that space, allow better airflow through the plant, and just a healthier growth form. So in this case, we have branches that are rubbing or impeding the progress of each other, and pruning would be appropriate. So this is another example of pruning for healthy form, healthy structure. Our goal would be generally to do this pruning when the tree is dormant, often coming out of dormancy at the end of the winter. For some plants that are moderately hardy, we might want to be careful about when we prune because of hardiness issues, but usually dormancy is a good guide for when to do pruning. We also may want to shape a plant and have it perform a role in a space. And so we might do some specialized pruning to a tree. So this is an example of, we're looking at London plane tree or London plane. This is at the Getty. And what you're seeing here is a small scale what you're seeing on this tree. So this larger specimen, pruning cuts are made on the branches. So they're set up as a framework and then chopped down, and many branches grow out of the cut location. This is often referred to as pollarding a tree. So you have a cut, and it's almost like this closed fist, right, where a mass of tissue happens. And then out of that mass of tissue, you get many, many branches that grow. Right? So if you're imagining the branch here and then all these branches coming out, when they leaf out, you get the effect in this left picture of a compact, small, rounded canopy. And the critical thing here is you need to make sure that all these branches coming out from the cut locations, that they never get very large, because so many of them are clustered together on the end of the branch that if they get large, you'll have structural failure. And that's not okay, right, for a managed landscape. So when you start to pollard a tree, you are in it for the duration. You need to continue to prune down so that the branches coming out of that pollarding cut stay small. If you decide you don't want to pollard the tree anymore, you would cut back below the pollarded space and get a natural branch formation to begin to happen again. But you couldn't keep those clusters where the pollarding was being accomplished. So this is a specialized form of pruning on the plant to get a more compact but rounded form on a tree. This is really popular in some parts of Europe, and we do some of it here in the United States. It's far less popular where you have snow and ice, because pollarded trees are very sensitive to snow and ice damage. But in areas where you have a climate where snow and ice are not in the cards, then you may see pollarding as a more popular technique. When we're doing pruning, we could do an entire session on just pruning and the way you do the pruning cuts and the timing and evaluating which branches to cut and all of that. But you want to follow best practices using sharp tools, making clean cuts, spacing them at just above nodes, and for cutting any large branches, you want to use a 3-cut method so you don't get tearing or, as the branch releases. But all of that you can look up as best practices for pruning. You've probably already looked at that or studied that on some level. Mulching is the next thing we're going to look at. Mulching is another place where you'll see opinions expressed about which practices are okay and which ones are not okay. I believe mulching is really important to growing healthy plants, and I think it's a healthy and wise part in growing plants in California. And that is, mulches serve to buffer temperature in the root zone and also to preserve water. So if you have a mulched tree and a non-mulched tree, the mulched tree will be more efficient with water than the unmulched tree. So it's not just aesthetics. It's not just looking clean or trying to avoid weeds. It also is regulating temperature in the ground and trapping moisture underneath. If you want to imagine how that works, go outside and turn over a rock, right? And look at the trapped moisture you'll see underneath that rock, the damp soil underneath the covering. That's the effect you're getting with mulch, right? Or a covering. So you can use organic-based mulches. I really like to do this in many settings because the organic material will break down and enter the soil. And so you are improving the health of your soil. You're providing organic material that will feed microbes that are in the rhizosphere. So I'm a big fan of organic-based mulches. Barks, aged wood chips, old compost, they can be really effective as a mulch. You also can use stone. Stone is very popular in California as a mulch, and it also is effective at temperature buffering and trapping moisture. So when you are using a stone mulch, that's nothing to be ashamed of. It can be very valuable. You're just not adding organic matter back into your soil. But here's an example of a nice stone mulch around a tree. One of the beauties of stone is you don't have to replace it frequently, whereas organic mulches, you're going to be looking at potentially turning them in a little bit and then replacing them as they break down on the soil surface. One thing to think about with mulches is to think about the goal of, do you want to be adding organic material back into the soil? Is that a goal? And also, how is the mulch going to affect the aesthetics of your landscape? Now, beauty is in the eye of the beholder, right? So the person who wants to look at the landscape, their opinion is the right opinion to listen to. Personally, I think most of the dyed mulches look really fake and artificial, and I cringe when I see them on landscapes. The other thing, though, that I think about is, so this mulch is rather reddish colored, and here is a coprosma that looks like it is fully camouflaged. You almost don't see it in the landscape. So this is a poor combination of mulch and plant, unless the goal was to hide the plant. So when we're thinking about a mulch, part of the role of selecting a mulch well is thinking about how it complements or fails to complement the plants around it. How deep should a mulch be? Anywhere from 1 inch to 3 inches is often a good depth. But the one thing we know is we don't want mulch volcanoes. We don't want mulch piled up against the stems of trees. When you have that happen, you're going to end up with, basically you keep the bark wet down right at the interface, down at the bottom by the ground, and it provides a place for breakdown in the mulch, for pathogens to enter the tree, for insects and pests to damage the tree. So mulch volcanoes or stacking mulch up against plants is a really bad idea. The goal would be no mulch up against the stem or tree itself. So that is mulching. Fertilizing. Fertilizing is something that may or may not be required. There are many products that are out there. I'm not directly endorsing the Espoma line products. I sold them when I was in the nursery industry, but I used other products too. I just happen to have a picture in my files of these products. So you might ask the question, do I need to? If you have a good clay soil and you're growing something that isn't forming large flowers or fruits, you might not need to add nutrients very often at all. For many shade trees, you do not need to add nutrients very often in a landscape. If you have sandy soil and you're growing a fruit tree, you might need to add nutrients every year or multiple times a year. So the question is, how does my soil and what plant am I growing, do I need to be adding a fertilizer? What I would recommend you as a best practice is, don't just dump on nutrients for the sake of doing the task. Look at the tree and the site and assess the need, because extra nutrients that you're dumping on are running off and are just waste. They're wasting your money and they're potentially harming the environment. So before you add nutrients, make sure that it's appropriate to add nutrients to your trees or shrubs in your landscape. Last point related to proper tree care or landscape plant care, and that is irrigation. So when you plant a plant, don't forget that water needs are different during establishment than they are after a plant is established. So even a low water use plant will require a moderate or high amount of water when it's establishing a root system. Once it's established, then you can back it down to the low water use level. And also, this applies to when root disturbances happen. So this is a southern magnolia in a landscape where the homeowner decided to put in this little riverbed here, different crushed gravel, and they dug up all this area to put down stone and damage the root system of this tree. When the irrigation was being provided to the plant, there was no factoring for that damage. So the tree had been surviving with a low end of moderate water and doing just fine, but with all the extensive root damage that happened, it was susceptible and died during the summer because not enough water was present. So in this case, we didn't hit the water needs for the plant after root damage occurred, right? It was not appropriate. So remember that when you're looking at water, you can look up the expected water use. Something like WUCLs could be a good guideline. You can provide water through, ideally, an irrigation system. In California, you've got something running to the plant, you've got drippers or mini sprinklers, and you are irrigating your plant appropriately, and that works out just fine. If you're looking to establish a plant with extra water during planting time, you could use something like a tree gator. You can use a bucket with a hole in the bottom for a slow drip system if you're going to provide water temporarily, and then you want the plant to be very low water use and function off of irrigation predominantly. So we want to be thinking about how we get water when it's needed right after planting, and then phase that out or go to the appropriate level of water through our irrigation system. So we can look at something like, this is Bob Perry's Landscape Plants for California Gardens, where we're looking at the expected water use over time. So we can dial in the appropriate water to our plant based on WUCLs, based on guidebooks, based on experience sometimes that we might have as we perfect a system. There are many other factors related to caring for plants and keeping them healthy. That was a basic conversation about some of the factors involved in proper tree care and woody landscape care. So describing proper tree care, after the past few minutes of this video, or past several minutes, hopefully you're able to describe or talk a little bit about caring for a tree, some of the factors that are involved. So what do we have as we wrap up this video? Well, this last section is the case study section. We're going to demonstrate awareness of ecological and practical implications associated with woody landscape plants. So what's the bigger picture beyond just the flower of the plant, the way it looks, the way it fits into our landscape? How does it fit on a bigger scale, on a bigger picture? So we're going to look at some case studies, ask some questions. First question, should I plant citrus in California? You might say, of course. Citrus are wonderful. I mean, this home, you walk in under these lemon trees and you smell the flowers on them. You see the fruits hanging. It's beautiful. Wonderful, wonderful plant. I love citrus. I think they're great landscape plants, and I like the fruit as well. However, it's something we should think about in California. We have a pest in California, the Asian citrus psyllid, or ACP, and the actual psyllid itself is not that big of a deal. It's not all that serious. It does not cause major damage alone. However, it can vector Huanglongbing, which is citrus greening disease, sometimes called HLB. So this is a big threat. HLB has caused devastation in Florida, massive losses to the citrus industry in Florida. We don't want that to happen in California. And thankfully, because of the warning that Florida gave us, we're doing a much better job in California managing the situation. So in California, we do have Asian citrus psyllid, ACP is here. We've had a couple detections of HLB, but no serious spread. So if you're asking yourself, should I be planting citrus in California? The question is, are you potentially spreading the psyllid and then HLB around in the state? Because the more plantings we have of citrus that connect the map in California, the more the psyllid and HLB can move around the state. When it is broken up by space without citrus, we're safer. Our citrus industry is safer. So we have quarantines in place, and we've been watching very carefully about where citrus is being produced and where we've seen Asian citrus psyllid. This is being watched, and this is being examined. The University of California ANR website has a map that identifies where we have current known HLB infections, where it's been detected. So you can punch in an address and you can see how close your setting is to HLB, where it's been documented. And the advice they give is if you're in a 0 to 2 mile zone, you probably should not be planting citrus. If you're a few miles out, you should really carefully watch your plants. And then if you're farther than 5 miles out, you should keep an eye on the map. You should be aware of what's going on, but it shouldn't stop you from planting citrus. These are general guidelines, but it's something worth thinking about. We should be responsible in how we use citrus in California. It doesn't mean we can't use it, but we need to keep our eyes open and we need to keep listening to the current developments with ACP and with HLB. Next, are roses high maintenance and high risk in a landscape? You might say, well, what do you mean by that? Well, the high maintenance part, if you've grown roses, you might identify with that. So roses are beautiful landscape plants, wonderful plants. Floribunda roses, hybrid tea roses, grandiflora roses, many of them require a lot of work to avoid leaf spot, to avoid damage from pests, to keep them looking healthy. It takes regular pruning. It's an investment. So that's why we might say roses take work. They're an investment. However, there are some roses called shrub roses or landscape roses that are lower maintenance in general than many of the old-fashioned roses. And many of them now are beautiful. the flowers on them look very similar to some of the older traditional roses. So you can get roses that have a lower maintenance budget than old-fashioned roses. What about the risk part? Well, the risk part is something we've been sheltered from in much of California. If you've never heard of rose rosette, that's great, that's wonderful, but you probably will before too long. So we have rose rosette in California. It was first detected in California in 2017 in Wasco County, and then Bakersfield, it was detected in a home landscape. So we've had some detection in California, nothing in SLO County yet that I'm aware of. So you can look up on roserosette.org the current tracking of the spread of this pathogen. What rose rosette is a virus. So it's a virus that's been known since the 1940s in the United States, but had almost no occurrence. In 2011 and a little bit beyond, we started to see it becoming a serious problem. And it rapidly became very serious, to the point in much of the mid-Atlantic region here and moving across the Midwest, roses are not even being produced and sold in nurseries and garden centers. The nursery that I worked at, Bamerwald Nursery around Philadelphia, they do not sell any roses at all right now, zero. And that used to be, back when I was working there, that was in our top 5 landscape shrubs were roses. Totally gone, wiped out from inventory. So rose rosette causes a cluster of kind of like a witch's broom or a dense cluster of growth. This plant looks mostly healthy. In fact, if you didn't know about rose rosette, you might not see a problem here. But these clusters of growth will become more and more prominent. Eventually, you won't have any healthy growth that looks like this. And you'll just get these clusters of kind of witch's broom appearance. The stems start to get thick and develop extra prickles. They swell a little bit. The plant declines and eventually enters this very weak, almost dead, kind of dying out phase. There's no cure once a plant has the virus of rose rosette. It is vectored by mites. So at this point, breeding work is being done to try and find resistance to the virus. They haven't found it yet. So this is something to be aware of. As this becomes a bigger and bigger threat, then we may be cautioning against planting roses in some areas. It's entirely possible. And like I said, some parts of the country, roses are not recommended for home landscapes. So right now in California, this has not shaped our use of roses yet, but that time might be coming. How about, is a variegated plant going to need some special care? Or is a variegated plant like any other plant in my landscape? Well, we could start answering this question by saying, first off, well, a variegated plant can be variegated for different reasons. Some are variegated due to pattern genes, and some are transposons, or genes that move around in the plant tissue. But others are caused by a chimera. So what is a chimera? Well, if we think about mythology, we think about a creature made up of different beasts, right? Different beings combined into one organism. That would be a chimera in mythology. A chimera in a plant is when you have a plant that has multiple genotypes in the same plant. So what you see is in the meristem, you see a mutation represented by green here. And it can be either a sectoral, a mericlinal, or a periclinal chimera. A periclinal chimera goes all the way across the meristem where you have this mutation. And what this often looks like is sometimes referred to as a chimera sandwich, meaning that you have the non-chimera and then the chimera and then non-chimera all together. That leads to variegated locations or markings on a leaf. So this is a chimera, English holly. This is a place where we have just the mutation, just the tissue that lacks chlorophyll. Whereas here, the chimera sandwich, you have just a band around the edge of the leaf that lacks chlorophyll. In nature, plants don't tend to hold chimeras very long. They tend to outgrow them because lack of chlorophyll is weakness in nature. The plant can't compete with the other plants around it. So a plant that has variegated foliage will usually be less vigorous than a plant that does not have variegated foliage, because that light-colored tissue is space where you don't have the highly productive pigments that is in the darker tissue. When you have something revert to pure cream-colored or white-colored like this, usually it will die out and not survive on a landscape plant or in nature. In nature, what will tend to happen is the plant will lose the mutation. We see this, here's a variegated pittosporum, where we have a variegated form, where we have the cream margin and a kind of a gray dusty color in the foliage, and that is Chimera right here. The plant has reverted to lose the Chimera and gone all green, and this growth will be more vigorous and will take over and eventually dominate the variegated foliage. So if you are growing a pittosporum in a landscape that is variegated, or you're growing a variegated holly or a variegated myrtus, the first picture I showed you was myrtle. If you're growing those and they're variegated, you need to be aware that they'll be a little less vigorous than their non-variegated parents, right, where they would have come from. And that two, if you start to see a branch that loses the variegation, you should cut that entire branch out because it's not going to go variegated again, and eventually it will dominate the variegated plant. So variegated plants have an added level of care needed. You need to prevent them from reverting back to their normal form. That'd be something to think about if you're looking to get a variegated plant. One note about fruit trees. Are there downsides to landscape fruit trees? I'll mention this one quickly as we get close to the end of our time together here on this video. So citrus and avocado and pomegranate, all these fruit trees we can grow in California. They're beautiful. They do require a fair amount of water. They are susceptible to some pests. They are somewhat messy, right? They drop fruit to the ground, and they also expose you to the risk of visitors coming to harvest the fruit. I rented an apartment for a period of time in San Luis Obispo that happened to have raccoons and rats around the apartment harvesting the avocados that would fall to the ground because they like to eat them. And so there is the chance that you would be drawing in visitors that may or may not be a problem for you. So here's an orange. It's important to remember you have to clean up the oranges on the ground, and you might get visitors to this orange plant. Here's the avocado that is so loved by rats and raccoons and other creatures. Pineapple guava is one that, yes, pineapple guava can be good to eat, but it also can be very messy on the ground, and they'll shoot up in all kinds of seedlings all over the place if they fall to the ground and are not cleaned up. Pomegranates, they look uniform and beautiful on a store shelf, or when they initially form in the tree, but then they split apart, you get birds all over the place on them. It can be somewhat of a mess. So my recommendation for a fruit tree or a plant with fruit is that you need to know that you're getting into a situation with a high maintenance plant. It's going to have more needs to stay healthy, and it's going to require more care. This is the equivalent of having a messy pet. You need to know on the front end that that's the case, and you need to be okay with dealing with it. And if you are, you get back some of that fruit. You get something beneficial. But you don't want to walk into the situation unprepared. You need to know that work is required. Our final conversation, our final piece of information that we're going to talk about is, why do weeping plants weep? Weeping cherries are spectacular. Here is a picture of a weeping cherry in the spring. Flowers all over the place, no leaves yet. Absolutely striking. Well, weeping cherry is not a natural weeping plant. It is convinced to weep with some creative horticulture. Some plants naturally do weep. They grow vertical, they lose the upright growth, and they cascade back down to the ground in a natural weeping form. So if you just plant this and walk away, naturally it will weep. And they will reproduce and do the same thing. They'll grow into weeping form. Weeping cherry are not like that. If you harvest a seed from a weeping cherry and grow it, you get an upright cherry plant. It is not a weeping plant at all. So the weeping form is found by grafting stems onto the standard or the stalk, the main trunk, that then grow out and over and cascade down in growth form. So when we are growing these plants in a landscape, we need to be aware that the grafted part, the part that will grow up and down and weep, needs to be protected. So this is a picture I took in a landscape. I saw this in the middle of the summer and it made me chuckle. And the reason it did that is because I could see what was happening, right? It's green on green, so there's a little contrast. Let me show you the plants in flower. So this is what happened. The pink flowers are the grafted cherry. So the plant was grafted to arch down and have the form just like that first picture I showed you for weeping plants. Branches grew out of the the stalk, right, the straight stem here. Branches grew out of that trunk, and they are now growing into the natural form for the cherry, this upright white flowering appearance. You can see this big branch growing up. That should have been removed to protect the little weeping grafted branches that are growing down here. So when we have a weeping plant, we need to understand, is it naturally weeping, where we don't need to do anything to keep it in that form? Or is it a grafted weeping plant when anything that happens below the graft union is going to grow vertical and form a canopy above our grafted plant? If we are aware of this, we know what to watch for, and you can keep a weeping plant looking beautiful in weeping form if it's an artificially grafted one. If you miss that, it's generally past repair. These plants could not be restored to the full aesthetic value of a weeping cherry. At this point, your best bet is to just embrace this hybrid, or chimera, as it were, of cherry tree. So that was a brief look at some of the ecological or practical implications that come with woody plants. We could talk about these things all day long. And when we meet together to have a question and answer session based on this training module, I look forward to discussing whatever piqued your interest, whatever follow-up questions you have that you might want to talk about. So I hope that you enjoyed this conversation about woody landscape plants. I had an enjoyable time recording this, and I really look forward to talking with you in the future.